Hello students, secondary 1 chemistry. Today we are still in unit 4 thermochemistry. The lesson now is the method for determination of delta H, which is the change in the heat content of a reaction or the enthalpy change of the reaction. In this reaction, for example, water ice solid is changing into water liquid, and the delta H for this conversion, for this physical change, is plus 6 kilojoule per mole. The question is, what is the change in the heat content for the second one? Here is 1 mole, but here is 2 moles. So the heat change here, the heat content change, is plus 6 multiplied by 2, because here we have 2 moles, which means that if you have more than 1 mole as in the first one, 2 H2O multiplied by 2, 3 H2O multiplied by 3, 4 H2O multiplied by 4, and so on. Another example is in the reaction, the same reaction, this is the same physical change. For this physical change, what is delta H? What is the relation between these two physical changes? Here is solid converts to liquid, but here is liquid converts to solid. So both of the two changes are opposite of the other one. So delta H for the second one is minus 6 here. The answer is minus 6. Why? Because this change is endothermic, but the opposite one, this one, is the opposite of the first one, is exothermic. So delta H is equal to minus 6 kilojoule per mole. The first example is if the same change, physical change, then for this one, 2 H2O liquid changed into 2 H2O solid. We note that the second one, this one, is the opposite of the first. This reaction is the opposite of the first one, and also multiplied by 2 moles, but here is 1 mole. So delta H for the second change for this one is 2 multiplied by minus 6. The answer is minus 12 kilojoule per mole. In this example, nitrogen dioxide gas decomposes into nitrogen and oxygen. What is the change in the enthalpy of this reaction? We note that this reaction is the opposite of the first one. Nitrogen here is a reactant, but here is the product. NO2 is a reactant, but here is a product. So this reaction is the opposite of the first one. Also, this reaction, the second reaction, is half the first one. Here is 2 NO2, but here is 1. So the delta H of this, the second one, is the same, minus 66. No, but plus, because this one is the opposite of this one, and also divided over 2. So the answer is plus 33. This is the answer. Why? It is the opposite and multiplied by half or divided by 2. So this is the answer. In this reaction, what is the value for delta H of this reaction if we suppose that it occurs? We note also that this reaction is the opposite of the first one. Carbon dioxide here is carbon dioxide is a product, here is a reactant. and also multiplied by 2. So the answer of the second one, this answer here, delta H of this reaction, is the opposite of this one. So change the sign from minus to plus, and it is also multiplied by 2. So the answer is plus 4158, the opposite, and multiplied by 2. So we get this answer. This is the answer A, and so on. Here is using laws to calculate delta H. We can calculate delta H by using laws. The first one is delta H is equal to the sum of the heat contents of the products minus the sum of the heat contents of the reactants, which is can be written mathematically by in this way. Okay, delta H equal sigma H products minus delta H reactant. If delta H product is less than delta H of the reactant, if this one is less than this one, the reaction is exothermic. But if delta sigma H products is greater than sigma H reactant, the reaction is endothermic. For example, here calculate the change in the heat content for this reaction, and it is given that the heat contents of the substances here. This substance is called acetylene. The heat content of acetylene, this one, the heat content of carbon dioxide, the heat content of water. These are given: acetylene, carbon dioxide, and water, respectively. Respectively means in this order. So the answer is delta H equal 4 for carbon dioxide. These are the products. Okay, 4 by the heat content of carbon dioxide. Heat content of carbon dioxide, this one, 2 by this number, plus 4 by this number, and 2 for water, 2 multiplied by minus 285, multiplied by this number. Okay, minus for the product sigma 2 multiplied by the heat content of acetylene. This is the heat content of acetylene, this number, 2 multiplied by 226.75, plus 5 multiplied by 0, because the heat content of any element is there, and you can get the answer. This is another way, another method for determination of delta H in terms of the heat of formation, but the first one was in terms of the heat content of the substance. Here is a similar law: delta H equals sigma heat of formation of the products minus sum of the heat contents of the reactants. In the same way, you can complete this delta H here. If delta H is negative, the reaction is exothermic, and if delta H is positive, the reaction is endothermic. For any substance, if the heat of formation of if any substance is negative, this means that this substance is stable, thermally stable. But if delta H of formation of any substance is positive value, we say that this substance is unstable because it contains a high amount of energy. For the element, the heat of formation of any element is 0. For any compound, the heat content or the heat of formation of any substance of any compound is greater or less than 0. This is an example. If you have this equation, If you knew that the heat of formation of the substances H2S hydrogen sulfide, this is the heat of formation of hydrogen sulfide, this is the heat of formation of hydrogen fluoride, this is the heat of formation of sulfur hexafluoride, this compound is called sulfur hexachloride, this is fluorine gas. You can answer in this way: sigma H delta H equal sigma H formation for the products minus sigma H of formation of the reactants. These are the products multiply for hydrogen fluoride. These are the products 2 multiplied by heat of formation of HF, this number 2 multiplied by HF, 2 multiplied by this number, plus 1, here is 1 mole, so don't multiply this, minus 1220 minus for the sum of the heat of formations of the reactants. For hydrogen sulfide, this is 1 mole, this is the heat of formation of hydrogen sulfide, minus 21 kilojoule per mole. And this is 4 by 0 heat of formation of hydrogen of fluorine gas. This is an element 4 multiplied by 0. You can get the answer in this way. Now I hope that you understand how to find the value of delta H. Thank you for listening.